So using the perpendicular axis theorem as we observe on our equation number 50 and also our equation number 59. So the moment of inertia along to the z-axis of the disk about an axis through its center and also the perpendicular to its plane or z-axis can be expressed as this one. Now we could say that moment of inertia through the z-axis must be equals to the summation of the moment of inertia along to the x-axis. Now then we add by the moment of inertia along to the z-axis. Now because these are similar, now we can say that moment of inertia along to the z-axis must be equals to the moment of inertia to 2 times the moment of inertia along to the x-axis, or is equals to 2 times the moment of inertia along to the y-axis, which is equal to 2I. Now we can conclude by saying that the moment of inertia along to the z-axis must be equals to 2 times the moment of inertia as we observe. So this should be the question number 61 for our fourth topic. So therefore, from equation number 61, the moment of inertia along to the x-axis and also to the y-axis of the disk about an axis along its diameter, or x-axis and also y-axis is given by this one. Now we should say that moment of inertia, as we know that we tried to see on our equation number 61, that the moment of inertia along to the axis is equal to 2 times the moment of inertia. Now we want to identify the moment of inertia. How can we get the moment of inertia? We should divide it by I from the moment of inertia along to the z-axis. Now as we observe here, the moment of inertia must be equal to the moment of inertia along to the z-axis. Then we divide it by 2, which is equal to 1 or divided by 4 mr square. Why we get this value? We know that the moment of inertia along to the z-axis, we tried to demonstrate here that is equals to a half times mr square. Kwa ukisubstitute hapa utapata kumbe moment of inertia must be equals to 1 over 4 times 1 over 4 times mr square along the diameter. So after this one, my dear student, let us go and see some examples related with what we tried to discuss here about the perpendicular axis theorems. So we have our example that is categorized into 2 parts. We have on Roman A and also on Roman B. So on Roman A, our example say that the moment of inertia of a disk about the diameter is given by as 0.05 kilogram meter square. And also if the disk has a radius of 0.2 meter, what is its mass? That if at the moment of inertia, we have the moment of inertia of the disk along the diameter, which is equal to 0.05 kilogram meter square, and also the radius equals to 0.2 meter. Now how can we find the mass of that disk? That is the question that we have been asked here on Roman A. So on Roman B, we have been asked that how does the moment of inertia of a disk about its diameter change if you double the mass while keeping the radius constant, and also how does it change if you double the radius while keeping the mass constant. So on Roman B, we have been asked to identify that how the moment of inertia could change if the mass the mass is doubled and also the radius remain constant, and also when the radius is doubled, how can we get the moment of inertia? That is what we have been asked on our question Roman B here. So let us start with the question on Roman A. We have been asked to identify the mass of the disk if we have the moment of inertia of that disk, and also we have the radius of that disk. Now how can we identify the moment of inertia? So on Roman A, let us start summarizing our given values into our equation here. So for our equation, we have the radius, we have the moment of inertia of that disk along the diameter, and also we have the radius of that disk. Now, how can we get the mass of the disk? That is what we have been asked on our question here. So the moment of inertia of a disk about its diameter is given like this one. So in order to find the mass of the disk along the diameter, we are supposed to remember the formula that we tried to demonstrate on the past session. But on the past session, we tried to demonstrate by saying that moment of inertia along the diameter must be equals to 1/4, then we times it by mass times the radius square. That is what we demonstrated on the last session. So as we see here that now from I is equal to 1/4 times the mr square. Now we are supposed to go and find the mass. How can we find the mass from our question here? Now let us multiply by 4 both sides, and after multiplying by 4 both sides, we are supposed to divide it by r square for the aims of making m as the subject. As we observe here that after multiplying by 4, tumeona kabisa kwamba at the right side yule 4 amebini cancelled kwa sababu atapatikana at the top pamoja na at the bottom pamoja na chini. Kwa wataweza kucancel, atahamia upande wa kushoto. Mwisho wa siku tuta make hii m as the subject, which is equal to 4 times I divided by r square. This is not a difficulty, my lovely student, because when we was in Form 2, we tried to learn on our topic of exponent and radicals. So at the end of that topic, we tried to see that there are some parts which is called the transportation computation, I think. We try to know how can we make the values at the subject. This is not a new terms for you. So as we try, so the formula of obtaining the mass of the disk could be equals to 4 times I then divided by r square. But I we have into our equation, and also we have r. Now we are supposed to substitute the value that we have been given into our equation, and finally we could solve. Na baada ya kusolve tutapata yule masi wa ile diski ambayo tumeulizwa ni sawasawa na 25 kg. Here, in order to get that 25 kg, we are supposed to take our calculator now and substitute our given values. Finally, we should obtain this value here. So after this one, let us go and see the question Roman B. On our question Roman B, we have been asked to find to identify that how the moment of inertia change if the radius is doubled and if the mass is doubled and one of them remain constant. Sasa yule moment of inertia atakuwaje? So if we recall into our formula, my dear student, we know that the moment of inertia is direct proportional to the mass. So if the mass change, even the moment of inertia will change. And also we know that moment of inertia also is direct proportional to the radius. So if the radius is changed, even also the moment of inertia will also change it. Kwa hapo tachoenda kukiangalia kama tutaweza kumdouble yule masi, basi na yule moment of inertia atabini double, ata increase by twice. Lakini kama tutaweza kumdouble yule radius, kwa sababu kuna square pale, kwanza kumbe moment of inertia atakuwa ni sawasawa, atakuwa ni force, temisi kwamba atakuwa ni 4 times the original one. So as we observe here that in order to identify that what will happen for the moment of inertia, we are supposed to recall our formula here as we try to see along the diameter. We know that moment of inertia equals to 1 or divided by 4, then we multiply it by mr square. Kwa tukitokea pale tumedouble, as we try to see if we double the mass, even also the moment of inertia will change. Finally, also as we tried to see that if we double the mass now, the moment of inertia will be twice with the original one. So also let us go and see when we double the radius and the mass remain constant, how can we get the moment of inertia? So if the new radius equals to 2 times the original one, so the moment of inertia using the formula must be equals to 4 times the original one. So this is how we can answer our question here. So by saying this, my dear student, this should be the end of our session here. Now I would like to welcome you again for another session. I wish you all the best. Have a nice moment.